Everyone thought, let's study here. Yeah.
Dedicated as well as Laitani, that I respect that.
Morning, like, oh, that's I never got punished in the morning. It was funny.
All right, guys, let's get going. Learning Unit 5 is probably the shortest learning unit and also the most important one because every year there's a big question from Learning Unit 5 that comes out in the exam. All the time, it's always like 15 to 20 marks. So it's actually easy. It's straightforward. You just need to remember some stuff, which we will do today. This should take us a maximum of 2 sessions, probably. If I can get everyone's attention for those 2 sessions, we can be done with this. So Learning Unit 5, the main thing we try to get to is this thing called truth tables. And it relies heavily on stuff we learned in Learning Unit 3, which I will summarize here in case we've forgotten that because it's been a long time. So let me mention also that truth tables, it's very much like logic gates. Any of you worked with logic gates before? A lot of logic gates? Okay. Maybe not yet because it's the first year. But the point is that you'll probably see logic gates at some point, and when you see them, there's no relation made to truth tables. So it seems like we're learning this for nothing. But if you look at them, it's a direct translation. It's the same thing. So when you learn logic gates, keep in mind that you've done it already before. Because most people start learning that and then they start from the ground up, but you don't need to, because we're going to learn everything we need here. All right, so truth tables. Let's start by defining a few things. All right, so we define an argument. This is something we're going to use later, but anyway, we'll define it now. Let's just read this part here. An argument is a set of statements, one of which is called the conclusion and the rest are called premises. So let's keep that in mind. So an argument, let's write this down here, is made up of 2 things. The first, the premises. So there could be more than one. Premise or premises, which usually leads to some conclusion. All right, so again, we're not going to use this directly yet, but we will need this later on. So I'm just getting it out of the way now. So an argument is said to be valid. Okay, let me change color for this part. Let's use the color red. So an argument is valid if the premises are all true at the same time that the conclusion is true. That's when something is valid. If the premises are true and the conclusion is true at the same time, then we say an argument is valid. So everything in red is necessary to be valid. We'll get into some activities just now. No, it's a bit abstract and a bit boring at the moment. We will get it out of the way. Okay, and we have a box here at the bottom that says before going ahead, it might be useful to recover some stuff from Learning Unit 3, which I have summarized here for you guys in the slides. The main thing we need, actually the only thing we need, is this purple box right here, which you guys might remember before. It's just this thing that tells you how different logical connectives work to give you truth values. Right, so this is really all we need for truth tables. So we'll start with the most basic version of truth tables. We're going to jump straight into that now. This is where the main part of this whole learning unit happens, right here, what I'm about to do. So try to be with me for this. Okay. So maybe I'll just recap one of these above, just to make sure we remember what's happening. So you guys remember P and Q are just labels for statements, and statements could be anything. It could be the sky is blue, the grass is green, whatever, right? Those are statements. So P and Q are labels for statements. And the first thing that we have up here in this box is an AND statement. Do you guys remember that? It's a P with like an upward triangle, Q. That's an AND statement. Okay, and the point of this box here is it tells you whether a molecular statement is true based on the truth values of the individual atomic statements, right? So, for example, in the first one, how do we know if this combined statement, this thing that I circled in blue, how do we know if that is true? Well, it depends on P and Q. We have to ask whether P is true and whether Q is true. And based on that, we follow the rule that's given in this table. The rule tells us whether the combined thing is true based on the individual truth values of P and Q. Right, so this tells us P and Q, the combined statement, P and Q is true when both P and Q are true at the same time. All right, so we've covered this quite a while ago, but it's just a summary, and we have rules for each different logical connector. So first for the and, then for the or, then for the if, then the if and only if, and then the negation. Right, again, if you forgot these, it's okay because we will recover them as we go along. Now let's try and use those rules to construct the basic truth tables that you can construct. So what I've done here is I've set it up so that we have one truth table per logical connector. Right, so I did one for the and, one for the or, one for the if then, one for the if and only if, and so on. So one for each one. This is a very basic way to do this, but from here we'll start building up. I just want you guys to see how we do this. So a truth table, firstly, we ask what statement are we analyzing? I'll start with the first one. We're analyzing the statement P and Q. We construct a truth table like this. We break it up into the basic statements. So P and Q can be broken up into P and then Q, right? There's nothing further we can break that up into. Once we have P and Q here, we just need to, let me actually construct it as we're going, right? So you guys can see how to do this. So if asked to make a truth table for P and Q, I will write P, I will write Q, then I will write P and Q. And the aim is now to get every possible combination of true and false for P and Q. That's what happens here. That's why we label these columns like this. So P could be true, Q could be true. P could be true, Q could be false. P could be false, Q could be true. P could be false, Q could be false. Right, so I'll show you a more formal way to do this in a moment, but can you see there? I've just put every possible combination true and false for P and Q. Once you have every possible combination, then you can work out every possible output. Okay, so I'll give you guys a moment to just be with me because this next part is important. Right? Firstly, everyone gets what I did so far. Just constructing a basic table. Now the output, we need to check the rule for the output. How do we know when P and Q is true? The rule says it's true when P and Q are true at the same time, right? That's the rule. That's in the purple table. So let's look at the first row. Does the first row satisfy that condition? Yes, it does, right? So we put true there. Does the second row satisfy that condition? No, it doesn't. They're not true at the same time, so false. Third row doesn't. And the last row, it doesn't, right? So that's how you construct these tables. Simple as that, right? You just follow the rule, you construct the last column. P and Q. So it's this one here, the first one, P and Q. So that's the rule. P and Q are true at the same time. So this is the same table I just constructed. Let me just fill it in here. True, false, false. And that's the same thing I just wrote. Yep. Yeah, you have to remember this. Unfortunately. Yeah. Okay, so let's try the second one, the second logical connective, which is P or Q. Let's check the rule for that one. P or Q is true when P or Q are or both true. So in other words, as long as one thing is true, then the combined statement is true. All right, so let's try and fill this one in here. Let's zoom in a bit. So in the first row, is at least one of them true? Okay. Yes, right. In the first row, we have at least one true. We have both true, which is even better. Second row. Yep. P is true there. Third row. Yes. Nice. Yeah. Q is true there. Last row. Nothing's true. So that's false. I'm walking us through this basically because just now we start building these up into much bigger statements. When we build them up into bigger statements, these tables become quite big at some point. So let's make sure we get this part. Let's do this other one for the implication. This is the one where people have trouble sometimes. The if-then statements. So an if-then statement is, let's check the rule for that. This one here. So it's true when P is false or Q is true. This or both here doesn't mean anything. Just forget about that. That just confuses things. True when P is false or Q is true. So that's what we need to get. Right. So I'll summarize the rule down here above the table itself. So this will be true when P is false or Q is true. All right. That's the same one. I'm just summarizing it here.
I'm saying that another condition.
No,
it's the same one as this one.
It's the same one. Same. I just yeah.
Why do you catch them? It's a long way down. Catching the school. Well, that's supposed to be. Yeah,
Yeah. I could leave it there, but it doesn't matter.
Let's say it's Q. They say Q first, then Q needs to be false, so
Yes.
okay, I got
Correct, correct. All right, so let's try and fill this one in. So I'm going to do this in a way that helps some people. Let's see if it does anything here. Change this color to red. I'm going to write the conditions that we need above the P and Q, right? We can see here, P needs to be false, right? So I'm just going to write that above the P. We know P needs to be false and Q needs to be true, right? Q needs to be true. So what we can do is just go down and see what matches. If something matches what I wrote above, it means it's true. If it doesn't, it's false. So let's check the first row here. Does anything from here match above here? The Q, right? The Q matches. So I'm going to put a circle there to say, yes, that matches. So good, it's true. Right? Second row, does anything match? I don't see any matches. There's no matches, so I'm going to say false. Third row, does anything match? We got a double match here. Perfect, so we'll say true. Last row, does anything match?
Yes.
The P, right? The P matches. The matches, so I'll say true. Okay. Okay, does anyone need me to go through this one again?
Please.
Do this again?
Yeah.
All right, let's do it again. Let's pretend we didn't do anything and let's redo the whole thing. All right, so again, what I wrote above here is just a summary of it. We need P to be false and Q to be true. All right, so I just go down row by row and see whether each row matches what I have above. All right, so right here, do we have anything that matches up here? Here there's no match, here there's a match. So because there's a match there, we say yes, it's true. Second row, do we have a match? Ooh, no match, right? It's completely opposite of what it needs to be. So it doesn't match, so I'll say false. Third row, the Q matches. It's true. Fourth row, the P matches, so it's true. Okay, guys, everyone okay with that?
Yes.
Yeah. All right. So I'm going to give you guys a moment to try the next one. You need me to show you the rule. All right. What is the rule? True when P and Q. both true. Let's write that up here. So this is 2 P and Q are true. P and Q. Well, I can take 1 minute to try this one. It shouldn't take too long. The rule is above here in red. Too easy. Yeah. That's good. That's good.
I didn't look at that.
Yes, the only post. I think it's easy to one music.
Okay, guys, first row, do we have true or false here? True. Second row, false. Third row, last one. Okay, perfect. You guys got it. Okay. All right. So I guess we get the gist of truth tables for the most part, at least these simple ones. The last one, very easy, the negation, right? Negation is just opposite of what the original is. So if P is true, the negation of P is false. If P is false, the negation of P is true. You just flip it. So there's our results here. Let's just check with the solutions at the bottom. True, false, false, false. True, true, false. Perfect. Thank you. All right. So now we're going to start combining things and making slightly bigger statements to make truth tables. So I thought it'd be time for a break now, but it's only 25 past. So we should probably do this first. Okay. So this one here, again, this is where things start getting a little bit confusing if you're not sticking with the logic. So don't try to overthink these things. It's simple, just like we've been doing. It's straightforward. So here we have a truth table for the statement not P or Q. So we'll start in the same way that we did before. We'll make a table for P and Q. Let me make that a bit bigger maybe so you can see it. P, Q. But now we try to move as incrementally as possible up until we get to the end point, right? So it will help if we have a not P here. So let's put a not P column, and then we can put the final column not P and Q. Right, so as incrementally as we can go, that's what we do, one step at a time. And then we do the thing where we make our 4 columns here for all the values. So just fill in your true, false values here. True, true, false, false. False. Well, we just pull this in to have every possible combination of true and false. Right? There's maybe not one way to do this, but this is just a usual standard way.
Oh, it's standard.
Yeah. I'll show you just now a more detailed way to do this. All right, so I'm guessing that if I leave you guys to fill this in, you probably can. Right? You guys want to try before I do it? Yes. Okay, give it a try.
So one of those stores is. Yeah, but one of them, one of them is a piece. No, it's not. Yes, yeah, I think that I think. I think they're a bit bad.
Don't underestimate Omar.
Yeah. But something like over next to me.
Only in Tani though, that's okay. Don't worry, Omar, Tani takes years of practice. Even I still don't get it fully yet. Yeah.
I said, yeah, you know, someone saying blah, blah, blah.
Yeah.
No, come on.
Every time I always call double, they say you can't call double on the corner house for more.
You can't.
Every time, every time, yeah.
Unless they. I don't know anything. But you should play with us sometime.
Yeah, I don't you guys to see me at my weakest point.
You don't judge. Out loud. Okay, sir, I played out loud.
Okay, guys, everyone done?
Yeah.
All right, so the not P is just opposite of P, right? So I'm going to put here true. No, sorry, already wrong. That should be false. False, false, true, true. Now, once that is done, it's important to note the P is irrelevant, so we can skip that part. Just forget about it. Right? We don't need the P anymore. This is now an or between not P and Q. Not P is its own thing, right? So we need at least one thing to be true to make this true. So in the first row, I see the Q is true, so we're happy. Sorry, first column, first row, yeah? Second row, we have a double false, so that doesn't help us. Third one, we're good. Fourth one, we're good. Okay. So this is an or statement. So as long as we have one true, the entire thing is true. Right? So it's important to note that once we have made a new variable, it becomes, you could make it another letter if you want. You could call this, I don't know, R, for example, and write your R for Q if you wanted to, right? If this confuses you. Yeah. Yeah. The last column. So we did an or statement first, right, in the beginning. Was that one okay for you guys? Did you get it?
Why does P become irrelevant?
Because we already used P to make not P. So the information is here now.
The should determine not P and Q.
We just use the not P, which we already created, and the Q, which is here. So that's all we need. So for an or statement, we need at least one statement to be true. Yeah, we only look at, we don't need to look at this for I'm saying, because we finish using that. That makes sense. Okay. All right, guys, this is new stuff. So if you have questions, don't be afraid to ask. All right, so far, everyone okay? I shouldn't ask it like that. Anyone has questions? Okay. Maybe I should ask this. Anyone give a damn? Okay, not a single person said yes to that. All right.
We didn't think
That's true. That's true. Got me there. All right, guys, make sure you understand this one. I'm going to leave it up for a minute, a few seconds, look at it, because the next one is a bit challenging. Right? We have to think about the next one. So the next one is about as hard as these things can get, which is a good thing. If you know the next one, you know how to pass in the exam, at least this section. Someone said, what exam? I like how Omar just now looked you dead in the eye and asked you, why did he do that?
that key that we had at, to explain this thing.
Yeah.
Right? Gives me the chemistry PTSD. You're doing like conjugates and this thing, and you put the C on the annexure.
Oh, wow. Oh, so I don't want to bring back trauma, so let me just take it out.
Yeah, the physics is also fine.
Physics was Yeah.
Skateboard with the bag, I'll do that. Don't ask me.
Yeah.
And then finally enough, like one of our maths questions in the shape on the person kick the ball in the air and then you calculate the time it reached down and so our class being in physics class, we all use physics and all, to say that it's a blah blah, the time takes somewhere comes down. But we got to do this. I don't know how.
Oh, yeah, yeah.
Why? Somebody give us an answer why we're going to.
It's those old-fashioned teachers that have only one set way of doing things, and if you do something slightly different, they. Okay, guys, let's do this one big example. We have enough time. Get out of the way before the break.
Yes.
All right. Okay, so analyze the statement is about monopoly. We have to now analyze the statement using truth tables. This is a typical type of question you will get. Given a statement with words and say analyze it using truth tables. So let's first break this up into some variables which we can call P, Q, R, whatever, right? So we can make a truth table. Let's read the statement first. The statement says, if you get more doubles than any other player, you will lose. Or that if you lose, you must have bought the most properties. It's a weird, mixed, complicated statement. So let's break it up into individual statements. All right, so the first, clearly we can see some if-then statements going on here. If something, then something, if something, then something, and there's also an or here. So let's break this up as far as we can. If you get more doubles than any player, you will lose, right? So that's the first statement. You get more doubles than any other player. Let's give that a label. We'll go with P since we always use P and Q. So P is you get more doubles than any other player. I'll just write it here. If you get more doubles than any other player, you will lose. So that's an if-then statement, but there should be a comma here, I guess. Just for English purposes, doesn't really matter. If you get more doubles, then you will lose. Okay. So we will call that one Q. You will lose. Okay, then after that, we have something separated by an or and another if-then statement. So after the or, it says, if you lose, so we need to make a new statement here. No, we don't because we have this, right? So perfect. Let's use Q. If you lose, comma, you must have bought the most properties. I'll put that in the wrong place. If you lose, comma, you must have bought the most properties. So let's call that R. Okay, so do you guys want to try to construct the molecular statement before I do it? Right, so something like if P, then Q, or whatever it is, right? Just try and build that up. I'll give you guys a few seconds to do that. Former students.
Will be us.
Yeah, I used to give them this thing called a joke break, but I don't do that anymore because someone once told a very offensive joke and I almost got in trouble. So
I was not being recorded.
yeah, yeah, yeah.
What if they did that for you? And I believe if you can see three of best of stuff. Best.
Yeah. If you guys want to hear the joke, you can come see me after. I can't, guys. It's offensive to women, the joke. It's bad. It's bad. It's fine. Who are we to say it's fine? We men cannot decide for the woman if it's fine. It's probably not fine. Probably not. Can I say we men in this day and age? I don't even know anymore.
You should be.
Should be able to. Okay.
Did you hear that?
Guys, before I go further and get in trouble, let's continue with the example. Okay. Okay. Yeah, I think we say it. We okay? Should be okay. All right, so let's construct the statement. So it says if P, then Q, right? That's the first part. If you get more doubles than any other player, which is P, you will lose, which is Q. So that's just a if P, then Q. That's the first part. And now we have this separated from something else by an or. So let's put a bracket here. Oops, and make an or. And what happens after the or? It says if you lose. So that's if Q. All right, so we start with Q there. If Q, then R. So this is probably the hardest part. Once this is done, the truth table is just following logical steps. Here we have to kind of interpret a little bit. This is a big one. It has 3 variables, so we have to learn a few, not really tricks, but okay, I'll show you guys when we get there. Okay, guys, when I start this, it's probably going to take somewhere from 5 to 10 minutes to finish. So it's going to go into the break. So are you guys okay with that?
Yeah.
I'll give you the time back. Okay. All right, so let's make the truth table for P, Q, and R. So first thing is that the number of rows that we have in the table depends on the number of primary variables we have. So here we have 3 variables. All right, so originally when we were working with 2 variables, we had 2 to the power of 2 rows, which was 4. Equals to 4. If we were working with 1 variable, let me write it like this. So I'll write 2 variables instead of just 2 here. So for 2 variables, space here, make space, 2 variables. Okay. For if we had 1 variable, for example, just showing you guys the pattern here, it will be 2 to the 1 rows, which is just 2, right? And we've seen that for the negation example, just with P. So for 3 variables, it's going to be 2 to the power 3 rows, which is 8. We have to make 8 rows. And with that 8 rows, we have to carefully design it such that there's every possible combination of true and false, which can be a bit tricky. So I'll show you guys a nice way to do that. Okay, I'm already running out of space here. Okay, we can make it work. P, Q, R, start here. And let's first fill in everything we need to get to that statement. So at some point, we're going to need a if P, then Q. At some point, we're going to need a if Q, then R. And then we can do the combined thing. PQ or so that's just going as incrementally as we can to get to the final step. All right, and you see at the end, we end up with the final statement that we want. Let me zoom in a little bit more. Okay, does this incremental progression make sense to you guys? Step by step, right? Okay, step by step. Now we have to fill in the true and false values here. And I'll show you guys the easy way to do that. Let me first make our 8 columns. Rows, sorry, 8 rows. I'm going to keep messing that word up, so just bear with me. Yeah. So that's up here. That's right here. So it depends on the number of variables. So the rows is 2 to the power of the number of variables. 3 variables, Q and R. Yeah. All right. So I'm going to make 8 here. So only I have 2, 1, 2. Okay, so I'm going to show you guys this unofficial trick one time. It's helpful to make sure you have every possible combination of true and false. I'll change color for this. So the idea is that in the first one, the first variable, which is P here, we divide these 8 into 4, 4 and 4, right? 4 above, 4 below. In the 4 above, we just put all true. In the 4 below, we just put false. So we just divided it into half. Right, we'll go incrementally so I don't lose anybody. Just make sure you get that down before I do the next one. Okay, so for the next part, we look only at the first 4, the parts which we labeled true already. Assume that to be a segment by itself. You can divide it if you want to. I'm just putting that line so we can see that there's a division there. Above is true, at the bottom is false. And then we do the same thing we did here. For the truths, divide that into half, make the top half true and the bottom half false. Right, so there's 4 here. So I make the top half true and the bottom half false. And then at the bottom, do the same thing again. Top half true, bottom half false. Top half true, bottom half false. All right, and we just keep on doing the same thing, incrementing it into half all the time. And top half true, bottom half false. Right, so no matter how many variables you have, you keep on just dividing in half, top half true, bottom half false, and you'll get every possible combination. Right, so I'll do it for the last one. So here we have the division happening here, here, and here. So top true, bottom false. There's only 2 here. So it's going to be true, false, true, false, true, false, true, false. Guys, if I get stung, please save yourselves. Okay, guys, do you want a break before we go on? Finish it. Okay. All right. We can finish it if I can talk though.
Yeah.
Okay. Good. Are you guys panicking about the wasp? Okay. Right. Okay, so let's do the implications for P. So the implications can get confusing here because now we have a if P then Q, then a if Q then R. So it might help to write this a bit cleverly so that we don't confuse ourselves. So we know that an implication is true if P is false or Q is true. That's the rule, right? We can always go back and check that. But now because we have P and Q as labels here and then it changes later, that can get confusing. So let's just change the labels in the rule. We'll say it's true if, what can I call them? P, Q, R. We can't use T because that's true. Let's use, let's call it S1 and S2 for statement 1 and statement 2. So it's true if S1 is false or S2 is true, right? Those are placeholders for whatever our variables are here. Because it could be PQ, it could be QR, it could be anything. I'm just giving it some name. So let's work with the first one. Here we know P needs to be true, right? So the implication if P then Q, we know P needs to be true. So let me write this in a different color. I'll do the same method I did before. P needs to be true or Q needs to be, no, sorry, false, right? P needs to be false or Q needs to be true. Let's see if I wrote the right rule there. It's fine to me. First one needs to be false, second one needs to be true. Doesn't matter what the name is. Right? Okay. So now we'll do the method we did before, which is a bit easier to not make a mistake. Go down and see which ones match up here. As long as you get a match, you know that column is going to be true. So let's just go down and look for matches, right? First, this is a row, right? Yeah, the first row, we have a match for Q. So I'm just going to circle them. Second row, do we have a match? No. Yes, right? You guys making me panic here. Second row, I see a match for Q. Third row, no match. Fourth row, nothing. Fifth row, Q for both. Okay. Next one, we have a double match as well. Single match, single match. Now it becomes easy because everywhere we have circled something, that's where we will have a true for the statement. Right? Everything else we just label it false. So I change color for that, or will that confuse us? Just put it black. False, false. Okay. Yeah, actually, this is not so bad now that when we do it this way. It's not too bad. So let's do the same thing for the QR. Okay, I'll give you guys a moment to write that if you're writing. If you guys want, we can just work about extra 5 minutes after the break and then call it off there. Yeah. We'll finish, yeah. All right. Sorry, question? Yeah. You mean up there? Let's start putting more in that. For this statement to be true. Yeah. Yeah, again, it doesn't matter what these are, just in the beginning had to find out from the questions. But once we get here, whatever the meaning is, doesn't matter. Needs to be false. Well, this tells us all the possible values. That's why we listed it in the beginning. Yeah. So there are instances here where P is false. That's where I circled it. So I heard you busy with tasks. I finished the game. Yeah, so we're just following the list. We might get something like that. That's it. Yeah. Okay, guys, I'm going to do the same thing now, but for the next one. For the if Q then R, So we just need to know the first part needs to be false. So I'm going to label this in a different color. So Q needs to be false, or R needs to be true. And let's just do the same thing. Look for matches at the bottom. So where do we find a match? First row, I see a match here. True. Next one, no match, right? Third one, no, we have a double match here. We're looking at red. Okay. Double match, single match here. Then we have one here. One here. Or double here, right? Okay. You guys okay with the way I did this? All right, perfect. Now, wherever we have a circle, we can say true. One or two circles is good. We can say true for those. Everything else is false. Okay, and actually, we're pretty much done now. Change the color one more time. What color can we use? All of these are very weird, ugly colors here. Pink. Pink. You vote for it, I'll take it. Who's it pink? Yellow. Yellow, okay, that's for yellow. Let's do a slightly darker one. It's okay, guys. We'll learn no matter what the color is. It's okay. Okay. So now I hope you guys can see for the final part, the only information we need is here. Right here. Everything else to the left of this, we don't need anymore. Right? Because we've done all the work already. So all we need to just make all comparisons between this and this. That's all we need. And we have the true and false values here, so we can do that very easily. An or statement is true if we have at least one true. Right? So in the first row, we have a double true. That's good. Second one, we have a single true. That's all we need. Third row, single true. Fourth row, single true. Fifth row, we have something actually everywhere. Everywhere, right? So it's all true. Okay, so more important than that is whether you guys understand what I did here. Yeah. Right, start to finish, all good. Okay, so with this, we get a bonus, right? With this, we learn something else called a tautology, which is a statement which is true irrespective of whatever individual atomic statements are. So this is a tautology because no matter what P, Q, and R are, it's always true. Right? So that's a tautology. The word is summarized down here somewhere, in case we forget it, down here, tautology. Okay. That's something. Okay, so we're doing well so far. Yep. Yeah, it will be. Probably 2 or 3. Let's just see how many we have there. Okay, guys, if you need to take a picture, take this down, whatever, just do that now so I can move on. Because I can see everyone wants to leave now, so try and rush a little bit. Also, this will be uploaded, so in a video on my channel, yeah. Please like, comment, subscribe. Like and subscribe. Like, no comment. Sure. So you have these two comments. We'll make you show. Everything on your videos. Yeah. I didn't monetize it, so there's no ads for you guys to study. It's okay. See ya, you guys have such short attention spans. 1 20-second ad, you'll be out of that video. Okay, so guys, I can see everyone's eager to leave now. So, do you guys want to do one more example? Yeah. Do you guys want me to give you as homework and we can try it next time? Okay, democracy, right? Who wants to do one more example here before we go? People didn't come to work today. You can. Who wants to leave now? We got divided.
Guys, do it as a homework.
Okay, guys, this example will take 5 minutes. I can do it right now.
Okay.
You guys okay with that?
Yeah.
I can do it right now. Okay, you guys can do it with me. Try it with me, right? Okay. Guys, actually, like I'm depriving you so much. It's not even 11 o'clock, man. Okay, guys, one more example. So let's look at this one here. You guys want a break? You guys want to have a break and then come back? Son, take me alive if I you want to go home. Let's just do it. Okay, let's just do it. All right, so let's make, again, it's the same kind of example. We have some statement, make a truth table out of the statement. And at the same time, last example, we learned what's called a tautology. Here we're going to learn something called logical equivalence, right? So we'll do the truth table and then I'll show you guys what that means. So let's make a truth table. We have statements. It will not rain or snow. And it will not rain and it will not snow. So these are two different statements now. We have to analyze both of them in the truth table. So the first one, let's see what will that look like. Let me make it like this. Let's change color. P will be it will rain. Q will be it will snow. I think there's only two statements here.
There is not rain.
Yeah, so they're worded this in a weird way. So we can make the first statement by saying it will not rain or snow. That's the first statement. The second one is it will not rain and it will not snow. Okay, so we have to do both of these in one truth table. It's not too bad. It's not too bad. So it's just P and Q. So it's just 4 rows, this one. It's not more than that. Let's make a space for that. Okay, so I'm going to say P, Q. Let's make as many increments as we can. We make not P, not Q. Then we can make the final statements. No, actually, we need something else here, don't we? We need a P or Q. Then we can make the final statements. Not P or Q. Not P and not Q. Okay, so once we have the two statements, this is the basic way to break everything down into smaller parts in the table. I'll bring that up a little bit. If anyone has questions about how I constructed anything, please let me know. And if you guys want, you can just go ahead and start filling that in as well, right? You probably know how to. You can start filling it in and I'll do it as well so we can check. Do you guys want me to give you a moment of silence or do you want me to talk through what I'm doing? Oh, okay. All right. Okay. All right, so not P is just whatever P is, but flip it over. So not P will just be false, false, true, true. Right? False, false, true, true. Not Q is just Q flipped over. So that becomes false, true, false, true. Okay, and P or Q, we know how to do that. It just means that from the PQ section, as long as we have one thing true, then this is true. Right, so as long as we have one thing true, which is true everywhere except the last row. Right, as long as we have one thing true, then it's true. So that's true because P and Q are both true. Here P is true, then Q is true, then nothing is true in the last one, so false. The implementation helps now because the next step is easy. It's just the opposite of what we have in this step here. Just flip it over for the next step. All right, so the last step, sorry, the next step we say false, 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 true. Yeah, so just flip it over. Okay, is that okay with you guys? Yeah, all right. So the last one is just an and statement between not P and not Q. And statement means we need both to be true for the thing to be true. So does that exist anywhere here? Only in the last one, right? That's the only place where we have both of these true. Everything else above must be false. Oh, where did it go now? Okay, and with that, we have the last lesson, the thing which is called logical equivalence. So the question asks us to check whether these two statements are logically equivalent. We have the two statements here, and they have exactly the same values, right? So that means they are logically equivalent. If their truth table values look exactly the same, it means they are logically equivalent. Okay, is that all right?
So,
Yes.
yeah. Yeah, I don't have to ask, but I'm gonna ask.
Take your time.
Okay, wouldn't either one of them be redundant? So wouldn't be any point? Yeah, one of them.
Yeah, I
I
mean,
mean to show both of them.
only because they ask us to show both. So I get what you're saying, but the question basically says check whether they're redundant. And because we've done this, we checked and yes, they are redundant. Is another way of saying logically equivalent. Okay. All right, guys, any questions?
So.
Okay, guys, don't be bullied into not asking questions if you want to ask. Okay, guys, I'm going to be here for another 10 minutes or so. You guys can leave if you want to, and I'll see you next time. If you want to ask me questions, I'm still here. You're welcome to ask.
That's what I was.
Yeah, you can stay behind for that.
That's the joke.